Hello, and welcome to a digital mathematics lecture for Salt Lake Community College. In this video, we're going to be continuing and finishing up Module 9 for Math 1030, Probability, and we're going to be talking about our third section here, which is the concept of expected value. This video is probably going to be pretty short. I don't have too much to go through, but expected value is a little bit different, so I wanted to separate out from the rest. The expected value is something that you tend to find in things like gambling games or maybe insurances. Basically, what is the value of something that could go well or could go badly for you? Like if you're betting on something and it costs some money to bet on it, but you could theoretically win some money, what's the expected value of actually playing that game? Or if you're selling insurance and that you would make this much money for selling the insurance, but then you'd have to pay this out if something happens, like if it's car insurance and they get into a car accident. You'd either make money by them not being in accidents, or you'd have to pay out money to cover their insurance. Either way, we want to find what's the expected value for that, and we typically want to be in the positive. Now, to find the expected value, the formula for expected value as capital sigma, which represents the sum of x times the probability of x. It's really x sub I times the probability of x sub I. And what this means is that you take the first value, x1, and you multiply that by its probability. And then you add that with the second value times its probability. And you keep doing that on and on until you run out of values. This is going to be our expected value. Now, expected value is also going to be basically the same as the mean or the average for a probability distribution. So it works the exact same thing away as the mean. And it should kind of look like that. The formula for mean, as we had in the past, or x bar or mu, we had as the sum of x over n, however ways it can happen. Well, the probability is simply, okay, how many ways it can happen times or over the total amount of possibilities. We also had mean can be represented with frequencies as xi times the frequency of that over the total of the frequencies. Well, if I take this frequency divided by n, that is the same thing as the probability of x sub I. So this really is the same as the sum of x sub I times the probability of x sub I. Which means that this is the exact same thing as a mean, and we treat it as such. However, what you do need to keep in mind in all of these cases is that the expected value is kind of the extension of the law of large numbers, a concept that we talked about in the first video, which states that the more you repeat an action, or the more you repeat the trials in an experiment, the closer you should get to the expected outcome. This is going to be our expected outcome if we were to repeat this experiment over and over and over and over again. So if I were to play this gambling game multiple times, or if I were to sell multiple instances of insurance, what would be the expected value of each of those instances? I point this out because it's not going to be logical to expect this to happen in a single individual outcome. So doing this probability game one time, I probably will not actually get this exact expected value. It is very unlikely to do so. For example, if you're doing the lottery, most times lottery has an expected value of maybe something like negative 58 cents. That's what we could find for expected value. However, it is very unlikely that you'll actually have that actually happen. You play the lottery once, you're not going to lose exactly 58 cents. What it means is in the long run, you're going to lose this amount of money. So the expected value is something to consider for the long run. So expected value is something to consider for the long run. What do we expect to happen if we were to repeat this probability experiment many, many times? That's what expected value is, and that's how you need to consider it. A couple examples of these. And again, these are the only two examples I'm going to talk about. If you want to try them on your own, go for it, or at least try the second one on your own after we do the first. Please pause the video and do that. All right, you purchase a raffle ticket to help out a charity. The raffle ticket costs $5. That's going to be very important for us. So the raffle ticket costs $5. The charity is selling 2,000 tickets. So 2,000 tickets. One of them will be drawn, and the person holding the ticket will be given a prize worth $4,000. Compute the expected value of the raffle. Okay. Now, the best way to do this is to organize your information, and we're going to organize that with a table. It's not going to be as complicated as the conditional probability tables, but it does have a few things we need to focus on. First, we're going to have a column that represents my events. We're also going to have a column that represents the value, and we're also going to have a column that represents the probability. If we organize all these pieces of information, it should be a lot easier to consider. Now, with this raffle, the different events that you could have is that you could either win the raffle or you could lose the raffle. It's an A or B circumstance. It's a binary situation. You could either win or you could lose. Now, the value of these, if you were to win the raffle, it says that you would be given a prize worth $4,000. However, you also paid $5 in order to play this. So $4,000 winning minus $5 to play the game means that you got a net sum of $3,995. That is the actual value of winning. That's how much money you would gain total. Likewise, if you lose, you don't just walk away. You gained $0, but you paid $5. So that means that you lost $5 in this transaction. So there's negative $5 value there. So dollars. So those are going to be my values, and that's the kind of the trick to these you need to be careful with. Find each of those probabilities, or find each of those values, considering what happened both before and after the winnings. Now for the probabilities, it says the charity is selling 2,000 tickets and only one of them will win. So that means, likewise, for my probability, maybe I'll do that in purple. For my probability of winning, well, 1 out of 2,000 of those tickets will win. That means comparatively, or if I do the complement, I have that 1,999 of those tickets will not win of the 2,000. We want this to be a probability distribution, which means these probabilities add up to a total of 1. Now, with all that in mind, we have all of our pieces in place and we can find our expected value. The expected value of this raffle is going to be each value times its corresponding probability. So 3,995 times its probability of 1 out of 2,000. And then we're going to add that with technically negative 5 times 1,999 out of 2,000. Its value times its probability. Now, this middle here of plus minus, because this is a plus a negative, what we could also do is simply indicate this as minus that number. And then what we do here is put all this into our calculator, either one step at a time or all together. 3,995 times 1 out of 2,000. And I'm typing it in basically exactly how I have written there with parentheses in their corresponding places. If I put all this together, I get actually a nice number of negative 3. or in this case, negative $3. This would be my expected value for the raffle. Now, note, this does not mean that if I were to play this raffle, I'd expect to lose exactly $3. What this means is, in the long run, this is how much you'd expect to win or lose in each of those instances. So I'm not actually going to play this game one time and lose $3, because realistically the only things that could happen are that I either lose $5 or I gain $3,995. Those are the only possibilities that could actually happen. This negative $3 is something that can consider in the long run. For example, if I were to play this raffle game 200 times, then I could say, all right, well, 3 times 200 would mean that I would expect to lose, on average, about $600 if I played this raffle 200 times. That is something that could happen, considering winnings and losings, or wins and losses. That is how expected value is actually applied. Overall, though, it shouldn't be too bad. Just make a table to organize your thoughts, and it should be a lot easier to do. And I recommend trying the second example on your own first, then unpausing the video and seeing how you did. A friend offers to play a game in which you roll 3 standard 6-sided die. If all the dice roll different values, you give him $1. If any 2 match values, you get $2. What is the expected value of this game, and would you play? Okay, so this one's going to be a little bit more complex. So for events, value, and probability. Now, you don't always need to make this table. I just think it really organizes your thoughts well. Now, we have 2 different events here. If all the dice roll different values, so different values, versus if 2 dice match values. So if any 2 match. Now, the probability we'll get to in a minute, because that will take a second to consider. The values, though, are not too bad. If they're different values, as given in the description, it says, if all dice roll are different values, you give him $1. So that means that you give him $1. That means to you, this value is negative $1. Likewise, if any 2 match, that means you get $2. So that means if any 2 match, your value is $2. So the values aren't too bad. Just keep in mind, at least one of these should always be negative. What is the expected value of this game, and would you play? So we need to consider the probabilities. These are going to be the little bit of a tricky thing to consider. So in a game in which you roll 3 standard 6-sided dice. So we have, if I even draw those out, if I have 1 die here, I have another die here, and I have another die here. What we want to consider are what are the probabilities of getting different values. Okay, so what we then need to consider is the probability of getting different values. And what that means is that all of these are different. So the first one and the second and the third are all different, which means we're going to be multiplying them all together. Well, for the first die could have any of the 6 different options. It could pick any of them. So it has 6 different possibilities that it could consider. It could be any of those 6. The second one, though, has to be something different. So once one of those is chosen, it is now off the board. Only 5 of them can be chosen. So something like, if I got a 1, okay, that's fine. Then the other one could be a 2, 3, 4, 5, or 6. Or if I got a 4, that's fine. The second one could be a 1, 2, 3, 5, or 6. The third one, likewise, needs to be different than these other 2. So that means 2 numbers are out of the picture. So overall, if I multiply all these together, I get 6 times 5 is 30, times 4 is 120, times 6 is 36, times another 6 is 216. So that's the probability of getting all different values. 120 out of 216. Likewise, any two matching, probability of any two match should just be the complement of this. So 1 minus 120 out of 216. So that should be 94. Out of, oh no, not 94, 96, sorry. 96 out of 216. So 96 out of 216. So that would be me finding each of those probabilities. All right, now to find our expected value. Expected value here is going to be negative 1 times 120 out of 216 plus the value of the second one times its probability. So if we put these into our calculator just like that, 96 out of 216, we get as a decimal 0.33, but remember that the values are in dollars, so that means that this is 33 cents. And note that this is positive. Since it is positive, that means that on average, you're going to gain more than you lose. That's what this expected value is representing. This does not mean, again, this does not mean that if you were to play this game once, you're going to gain 33 cents. This means on average, if you were to play this a lot, you would gain about that much every time. So to answer the question of would you play? Yes, I would play. On average, I'm going to be gaining more than I'm losing, so this does seem advantageous for me to play. All right. With that said, that's everything that I wanted to talk about with expected value. I hope that this helped, and I highly recommend working through a lot of the questions just like this. Set up a table of events, values, and probabilities, and then you can find your expected value. A lot of them will not be as complicated as this one with the dice. Finding those probabilities took a little bit more work than most of them do. They'll more work like the first problem where the probabilities are more or less given to you directly. But I hope this helps. Go ahead and finish up the homework for Chapter 9 at this point. If you have any questions, feel free to put them in the comments, and I hope you have a nice day.